Hello everyone, welcome back to a new video. So in this video, we'll be solving a question named two-sum. So this question has two types. So we'll see both the types in this video. So what does the problem state? So we have been given an array of integers and a target. So we have to find two numbers from the array that sums up to the given target. So here we have been given a target as a 9, so we have to find two numbers from the given array that will be sum up to the given number. So as you can see, we have the number 2 and 7 from our array that sums up to a target. So in the type 1 of this question, we just have to return yes or no whether there are elements in an array which sums up to the given target. So if there are elements in the array that sums up to the given target, then we have to return yes. And if there are no elements in the array that sums up to the given target, then we have to return no. So here our target is 9 and we have two elements, the element 2 and 7, that sums up to 9. So in this case we'll be returning yes. And if our target is given as 8 instead of 9, then there are no elements from the array that sums up to the target 8. In that case we have to return our answer as no. So that was the type 1 of the question. So in the type 2 of this question, we have to return the index of two numbers that sums up to the given target. So in this case, our target is 9. So there are two elements from our array, that is 2 and 7, that sums up to the given target. So we have to return the index of two numbers. So the index of element 2 is 0 and index of element 7 is 1. So we have to return the index of the elements. So that was the type 2 of this question. So let's try to solve this question. How to solve this question? We have to find two numbers from the array that sums up to the given target. So the extreme brute force would be, I'll be taking one element from the array at a time, and for that one element I'll be iterating over the entire array and I'll be checking if there exists another element with which the sum of both the elements gives us our target. So that would be the extreme brute force to solve this question. So let's try to dry run this. So currently I'm at element 2 and I'll check if there is an element with which the sum of element 2 gives our target element. So let's try. So the my element is 11. When summing 11 with 2, it gives answer as 13, which is not equal to our target element. So we'll check the next element. Our next element is a 7. The sum of 7 and 2 gives us our target element, which is 9. So that is my answer, and I'll simply return yes if my question is of type 1, or if my question is of type 2, then I'll simply return the indexes of element 2 and 7, that is nothing but 0 and 2. So let's try to write pseudocode for this. So I'll need two loops. So the one will be iterating over the array. So for int I equals to 0 till my I is less than the n, and I'll increment my I. Then we'll need a second loop to check every other element for the current element. So for int j equals 0, my j should be less than n, and I'll increment my j. And we need to check if my element at I and element at j, if they are equal. So we are not allowed to take the same element two times. So if my I, if it is equals to j, then I'll simply continue. And if it is not, then we'll check if the sum of I and j, if it is equals to our target. If it is equals to target, then that means that is our answer. So if our I and j is giving sum as our target, then I'll simply return yes, or I'll simply return the indexes of I and j. So that is the brute force approach to solve this question. So let's talk about the time complexity and space complexity. So as we are iterating over array two times, so this for loop will be taking us big O of n, and inner for loop will be taking us big O of n. So the overall time complexity for this approach would be big O of n square. And talking about the space complexity, as we are not using any extra space, so the space complexity for this approach will be big O of 1. So that was the time complexity and space complexity. So as we are using the quadratic time complexity, that is n square in this approach, so can we optimize this to the linear time complexity? So let's try to see the better approach for this question. So the better approach to solve this question will be based on the concept of hashing. So in brute force approach, we are consuming the time complexity of n square. So my intention in this approach will be to reduce this time complexity to somewhere about the big of n or big of n log n. So I need to reduce my time complexity to optimize my previous approach. So let's suppose I am currently iterating over my array. In the brute force approach, we are iterating over each element twice. So in the better approach, we need to iterate over each element only one time. So let's suppose I'm iterating over the element 7. What is my need? So I need an element which when sum up with the element 7 will be giving me sum as my target, which is nothing but the 9. So how I can find the required element? So my target is 9 and I'm currently having element 7. So 9 minus 7 will be giving me 2. So I'm in need of 2, which will be sum up with 7 will be giving me the my target. So how I can find whether the element 2 exists in my array or not? So we can use hashing in this case. So I can use hashing to find the required element, which will be sum up with my current element giving me my target. So let's try to dry run this. So let's suppose this is my hash array and I am storing the index of each element with the element. So currently I'm at index 0, and at index 0 there is element 2. So I'm currently at element 2 and my target is 9. So which element I require? So 9 minus 2 gives me 7. So I'm in need of element 7. So I'll check if there is an element 7 in the left side of the array. So there is no element 7 in the left side of the array. So now I'll insert my element 2, which is at index 0, into my hash array. My hash array will be containing element 2, which is at index 0, and I'll move ahead. So currently I'm at element 11. So and my target is 9. So how much I need? So I'm in need of element which is nothing but minus 2. So I'll check if there exists a element minus 2 in the left side of the array. So there is no element minus 2. So I'll simply store element 11 into my hash array. So which is at index 1, and I'll move ahead to the next element. My next element is a 7 and my target is 9. So I'm in need of element 2. So I'll search element 2 in my hash array. So as you can see, there is element 2 which is at index 0. So I'll retrieve it from my hash array and I'll simply return the index of element 7 and element 2. So currently I'm at index 2, which is nothing but the index of element 7, and my element 2 is at index 0. So I'll simply return 2 comma 0 as my answer if my question is of type 2, and if my question is of type 1, so I'll simply return yes. That means that so there exists a pair of elements which sums up to a given target. So let's try to see code for this approach. So we need unordered map to store an element as a key and its index as a value. So I'll declare an ordered map of integer comma integer named mp, and we also need a answer vector to return indexes. So I'll also declare it, and we need to iterate over the array. So for int I equal to 0, I less than nums dot size, and I'll increment my I. So now we need to check what is the extra element that I am needing to achieve my target. So that extra can be easily calculated by subtracting my target from my current element. Now I'll check if that extra, if it is existing in my map or not. If it is not existing, then iterator will be pointing to the end of the map. If iterator is not pointing to the end of the map, that means my extra element is existing in my map. So I'll simply push the index of my current element into my answer vector and index of my extra element into my answer vector, and I'll simply break out of the for loop. If my extra element is not existing in my map, then we need to insert the current element with its index into map. So mp of nums of I is equals to I. So now when extra element is existing in my array and we are breaking out of the for loop, we'll simply return our answer vector. So let's try to run this on the sample test cases. So as you can see, it is successfully run for the sample test cases. Let's now try submitting this. Yeah, it is successfully submitted. So let's try to see the time complexity and space complexity for this approach. So as we are iterating over our entire array, so that will be taking us big of n time complexity. And if we are considering the map takes big of 1 for searching, then that will be the big of n time complexity. And if we are considering if map takes the big of logarithmic of n to find an element, so my overall time complexity will be big O of n log n. So that is my time complexity. And what about the space complexity? So we are using extra space in terms of the map. So my space complexity will be big O of n. So that was the better approach for this question. So let's try to see the optimal approach to solve this question. So the optimal approach to solve this question is based on the concept of two pointers and sorting. So it is very simple. So this is my given array, and if I sort it, my array will be looking something like 2, 7, 11, and 15. And I need to find two elements that are summing up to my target, which is nothing but 9. So I'll simply take two pointers. One will be pointing to the start of the array and one will be pointing to the end of the array. So I'll find the sum of two elements which are pointed by my two pointers. So the my right pointer is pointing to element 15 and my left pointer is pointing to element 2. The sum of the element is nothing but 15 plus 2, which is 17. As my sum is greater than my target, so I need to reduce my sum. If I increment my left pointer, my left will be pointing to 7, and in that case my sum will be 15 plus 7, which is nothing but 22. So in that case, if I am increasing my left pointer, my sum is increasing. And if let's now try moving my right pointer. So if I move my right pointer, so it will be pointing to 11, and my sum in that case will be 11 plus 2, which is nothing but 30. And in this case my sum is decreasing if I move my right pointer. So if we need to increase our sum to match our target, so we need to increment our left pointer, and if we need to decrease our sum, to match to our target, then we'll decrement our right pointer. So currently my sum is 17, which is greater than my target. So I'll decrement my right pointer. So my right pointer will now pointing at element 11. So now the sum of 11 and 2 is nothing but 13, which is greater than my target. So now I'll decrement my right pointer and my right pointer will be now pointing at element 7. So now my left pointer is at element 2 and my right pointer is at element 7, which will be giving me the sum 9, which is exactly equal to our target. So this will be ended up giving me my answer. So if we are trying to solve the question of type 1 in which we just have to return yes or no whether there are exist two elements which sums up to the target. So in this case we'll simply return yes. And if we are trying to solve the question of type 2 in which we need to return the index of the two numbers, so in that case while sorting our array we need to store the element with its index. So this will be 2 comma 0, then 7 will be 7 comma 2, then 11 will be 11 comma 1, and 15 will be 15 comma 3. So we need to store element with its index before sorting. So with this approach it will ended up taking some extra space because we are trying to store the index of the elements also. So that would be an headache. So if we I'm having an question of type 1, so this will be an optimal approach to solve this question when I have to return yes or no if there exist two elements that sums up to target or not. So that was the optimal approach to solve this question. So let's try to code this up. So first of all, we need to sort our array. So I'll sort my array. So sort nums dot begin comma nums dot end. Now we need a two pointer. The pointer left, which will be pointing at element at index 0, and pointer right, which will be pointing at element at index n minus 1, which is nothing but our last index. And we need to iterate over our array till my left pointer is less than my right pointer. And now we need to check if the sum of elements at left plus right, if it is equals to my target. If it is equal, then we'll simply return yes, and if it is not, then we'll check if my sum of element at left plus element at right, if it is greater than my target, then we'll decrement our right. Else if it is less than our target, then we need to increment our left pointer. And at the end, while our iteration over the array is completed, and if till now we haven't got our answer, then there is no two such elements exist in our array that sums up to the given target, then we'll simply return no as our answer. So let's try to run this. As you can see, it has passed all the sample test cases. Let's now try to submit this. And it has successfully passed all the test cases and it is successfully submitted. And indeed, we have solved this question.